We are given with a linear equation, the first derivative of y with respect to x, or dy over dx, plus 3x squared y is equal to x squared. Let us try to determine first if this is really in its standard form. The standard form of a linear equation is expressed in this form, dy over dx plus p of xy equal to f of x. This means that whatever would be on our right hand side is already in a function in terms of only one variable x. And we can also identify a certain function paired with y to the power of 1 as our p of x. These two are very important, or this is standard form is very important because we will be using the concept of p of x as we are going to look for our integrating factor, which is mu of x, given with this formula e to the power of the integral of p of x dx. Again, p of x in this form, and f of x is another function on the right hand side of the equation. We may not be using f of x in solving for the integrating factor, but it will be used in the further process. We will be providing you a separate video for the another process or the continuation of this specific equation. But let's focus first on our given function here, or equation, dy over dx plus 3x squared y equal to x squared. Undoubtedly, this is already our f of x, x squared. That's very obvious because your right hand side only contains one variable, and that's x. As for your p of x, look at the function beside or paired with y to the power of 1. This case, our p of x is equal to 3x squared. This time, we'll be using p of x in solving for the concern of this video, which is the integrating factor. Mu of x is equal to e raised to the power of the integral of p of x, which is 3x squared, and then dx. So simply take the integral of the exponent, and whatever will be the result, that would be our exponent of our e as our integrating factor. So our mu of x, which will be used in the further process, is e raised to the power of, take note, that is the integral of 3x squared. Of course, you will have 3 times, you have x cubed over 3. You have to remove, you have to cancel that. So you have x cubed here. Obviously, that would be your exponent. And of course, supposedly there should be plus c, but we don't need it right now because our integrating factor only looks for the first order derivative without the arbitrary constant c. So this is now our integrating factor as we look for further solutions of this given item. Again, will be provided by the separate video. Thank you very much for watching.